Okay, thank you very much everyone for coming to the lightning talks. Are you excited? Okay, so as you know, so we have one important rule this lightning talk session. So I asked all speakers to insert one talking point that will get a storm of applause. So when you find that point, please give a big round of applause. Is that okay? So let's practice again. So it's not working. Okay, so there are two numbers. So what does it mean? Do you have any sense about it? No. Modification is 94% down. Onion soup is 70% down. So many people contributed this effort. So this is our community contribution. So thank you very much for contributing. So we are aiming at 100%. So thank you very much. Okay, so I want to invite the first speaker to the stage. So Mason.
Okay, so I'm Mason Freed, and I wanted to tell you about a CSS property, a new CSS property called Backdrop Filter that I've been working on. So what is it? It's very similar to filter that you might be familiar with. Filter applies a graphical effect to an element, like a blur or a hue rotate or a grayscale. A backdrop filter is similar, except that it applies to the stuff behind the element, not the element itself, and that takes a little getting used to. Here's a quick example. You see a video element here with a div after it that has backdrop filter applied. And the interesting thing is that the blur and the hue rotate that you see there will be applied to the video and not the div itself. And the idea is that you can use this for lots of things, but typically a frosted glass kind of dialog box or a video overlay or navigation headers. So I'll show you a few examples, assuming they play. So forgive my visual styling, I am not good at that. But here you see a navigation bar with a blur applied to the backdrop filter, and the content underneath it as you scroll nicely gets blurred. More complicated example, a video playing with a dialogue over the top. And this one has the blur and the hue rotate, and as you move it around, you can see that the stuff behind the video, as it plays, gets blurred. You can imagine this is very hard to do, basically impossible to do with a polyfill. So that brings me to the next point. Why should we do this? And it's because developers want it, and they don't have a great way to do it right now. The bug that tracks this has 550 stars. Thank you. I had to cross that out. That was actually 547 a few days ago, so it's growing pretty quickly. It's number 10 right now overall in all of Chromium. And you can see a few of the comments there. People want this feature, so we should give it to them. Where is it right now? It is implemented. It's behind the experimental web platform features flag, so you can try it out if you like. It basically works. There are some open bugs, but they're getting smaller and smaller. We're hoping to ship this in M76, and if you're interested in more details, the links are there for the explainer and the spec. And I'm around as well if you have any questions. Thank you.
Thank you very much. So the next speaker is Yashar.
Hello, everyone. My name is Yashar. I'm an intern at Google. I'm going to talk about two things that I've done that are related to runtime features on Blink. Also, thanks to Ian, I don't know where he is, for giving me his lightning talk spot. Anyway, let's go ahead with the background on the runtime features on Blink. So they're all defined in runtime-enabled features.json5. You define a feature, it will generate a function for you, so you can call it to see whether the feature is enabled or not. So my first project was related to platform-specific features. So features are enabled on some platforms, but not on the others. For example, the fast mobile scrolling is only shipped on Android. So the way we used to correctly initialize it was to define it with no status, which means it's not enabled by default on any platform, then manually enable it afterwards. So what we did was to combine these two, with this kind of format, so you can specify the status on every platform, and it will generate the right code for you. Okay. So next project, this is what we like to call unified features. It's basically combining runtime-enabled features and origin trial features. For those of you who didn't attend Jason's talk earlier, origin trials, they let you enable a feature on an origin for a limited time. It's a great way to experiment without making the feature widely available. So what do you have to do if you want to put your feature in an origin trial? So first, you need to specify trial name, then you need to change the function call from runtime feature namespace to origin trial namespace. You have to pass it the execution context, and in the end, if your feature is exposed as a JavaScript object, etc., you have to change the ideal tag from runtime enabled to origin trial enabled. And if you want to ship it, you have to basically reverse everything. So although these changes are not a lot, we wanted to make your life simpler. So all you need to do now is just like add the trial name and pass the context to the previous function calls. And when you want to ship it, just remove the trial name. Simple as that. Thanks, everyone.
Thank you very much. So the next speaker is Scott.
So hi everyone, I'm Scott, and I want to talk to you today real quick about this thing a bunch of us have been working on, native lazy load support in Chrome, and we'll just blink in general, I suppose. So what's the problem here? Lots of sites often have images or iframes down near the bottom of the page, such that they're out of view, and this is all well and good, except for the fact that users don't always end up scrolling all the way down. Meaning that loading these resources ends up wasting device net resources like network, memory, CPU on the stuff that doesn't actually end up getting seen. So what can we do to try to fix this? So there's this concept, lazy load. It's not that new of a concept, but it is something that we do want to do. So with lazy load, the idea is we want to wait to load in these images or iframes. We want to wait to load them until the user actually scrolls near them. That way, if something's actually going to be loaded, it's more likely it's actually going to be seen. The idea with lazy load, as we're doing it in Blink, is to start loading in stuff before it's visible, such that it's typically fully loaded in by the time the user sees it, so that there's no stuff flashing in and out. The user would typically notice, they wouldn't notice that lazy load was on at all, except for stuff speeding up, and they're saving network data and also memory and that good stuff. One question some people might be thinking is, wait a second, are we already able to do this in JavaScript? And the answer is kinda. There are some cool JavaScript lazy loading libraries that sites can use to lazily load images or iframes on their own. But adding native support will make it much easier for sites to actually take advantage of these kinds of optimizations. For example, with native lazy loading right now, sites can just use an attribute, a loading attribute on images or iframes, like the adorable puppy image here. One other thing about native lazy loading is that it opens up the possibility of automatically lazily loading content, even if it isn't marked as loading equals lazy, when it's safe to do so in ways that don't break pages or page functionality. So the current status of lazy load right now, the intent to ship is out, and we're aiming to launch support for loading equals lazy in M75, which should be fun. Thanks. We're also, automatic lazy loading is also coming soon too. We're targeting Android Chrome users who have Data Saver turned on. You can try it out at home by turning on the flags in Chrome Flags. If you want more details, feel free to check out the intent to ship or the explainer on GitHub. Thank you very much.
Thank you very much. So the next speaker is Yang Su.
Okay, my name is Young-Soo Che from LG Electronics. Today I want to talk about our new browser, which the UI part is written by the web languages. LG already have a really good browser, and it is shipped to the products in the market right now. But and it is a native application based on the Chromium, of course. And it is like shipped more than from 5 years ago. But the problem is that in these days, we're trying to adapt this browser to a new category of products. But you know that if we want to adapt this browser to a really new category, then we have to re-implement all the UI stuff. And you know that in LG, there's only few people who can do that because there are many web developers, but not many web engine developers. So our idea was that why don't we try to implement the UI part with just the popular web languages like HTML, JavaScript, and CSS. And yeah, we made it. So this browser is open source, so you can download it from this link if you are interested. And the UI is currently almost similar to the TV browser in the market. And it uses the WebView tag inside the Chromium, so it only works on the Chrome browser or the Chrome-based browser, Chromium-based browser. And it is called Inect browser because it uses our LG open source JavaScript framework, which is called Inect. And Inect is actually based on React. This is the Inect browser is currently on the concept proving stage. So I want to listen to your opinion, any suggestion, or any concerns. So please contact me if you have any. Thank you.
Thank you very much. So the next speaker is Jonathan.
Hi, I'm Jonathan, and I work at ARM on the Chromium optimization team. And recently, I've been trying to get some more performance out of JPEG. So just a quick overview of the JPEG algorithm. So you start off with raw RGB image data. You transform to the YCBCR color space, so that's luminance and chrominance. We then do some chroma downsampling, so we can get away with throwing away some color data because human eyes see color data less well than light intensity. We then put that through a discrete cosine transform, and that's more complicated than I can explain in a lightning talk. You then multiply those cosine wave coefficients by a quantization value, and then you stick the output of that through a Huffman encoder, and then you get JPEG compressed data. And you won't be surprised to find out the decompression is just going back the other way. So the neon acceleration story in libjpeg Turbo at the moment looks like this. Given that this is Chromium, we can care mostly about decompression performance, and there is still quite a bit to be done at the moment on chroma upsampling. So that's the patch that I'm going to be talking about now. So chroma upsampling, these are the most common web sampling ratios. So H2V1 means that at the compression stage, we've thrown away every other pixel's chroma value to create samples. And in H2V2, it's the same, but also in the vertical dimension as well. And when we're decompressing, we want to get back to pixel values to as high a fidelity image as possible. So you could just duplicate the chroma samples, but you would end up with some artifacts. So we do some linear interpolation between pixel centers to smooth some of that out. So here's what the maths looks like for H2V1. And this pattern is vectorizable using neon. And it's the same principle for H2V2, just you need to blend in the vertical dimension as well. So after writing some neon code to accelerate this, these are the average performance uplift values. So on a big core, we're reducing overall JPEG decode time by 20%. On the little core, it's 29%. But some images show performance uplifts of up to approaching 40%. So these patches are part of a major code rewrite for libjpeg Turbo. The upstreaming situation is complicated, but we aim to get it into a shipping version of Chrome sometime later this year.
Thank you very much. So the next speaker is Nick.
Hello, everyone. My name is Nick. I joined the Blink Input team 2 months ago. I'm going to talk to you about the first project I'm working on, which is text URL fragment anchors. So a URL fragment anchor today looks like this at the top. So we have a URL followed by the hash symbol and then element ID, and the browser loads this web page and then scrolls that element into view. The problem with this is that it's hard to share specific information on the web page. For example, the relevant text that you want to share may not be near an element ID. So text fragment anchors allow us to link directly to some text, and then the browser can scroll to this text and even highlight it to indicate what they're being linked to. So here's the syntax that we've proposed for it here. So we have this target text identifier, and then a few parameters. So there's only one required parameter, text start. So you can simply say target text equals, and then a string of text that you want the browser to find and scroll into view and highlight. But you can also specify a text end, so you can specify a text range that you want to be highlighted. And then, of course, this could be ambiguous, right? So there could be multiple instances of the text range that you're trying to specify. So we also propose these context terms where you could specify the prefix and suffix. So I have an example here where you would need the prefix and suffix. So if you wanted to indicate specifically Christopher Nolan, his director position on Inception, you'd have to provide the prefix Inception and the suffix director. So here's an example of one use case, so a search engine. So here's a Google search result where we provide the text blurb that tries to answer your question, and then the URL link where we retrieve that text blurb. But the problem is if you click this link today, it'll just take you to the top of the page, and you don't necessarily know where that text answer came from. So with text fragment anchors, the search engine can link directly to the answer. The page will load, and scroll into view and highlight the answer. So here's another use case example. So just a reminder of the syntax at the top there. So user sharing, so the browser, you can imagine, could implement something like copy link to selections. So the user could just highlight the text, and then the browser could generate a link to it, or even do some processing and generate the text start and text end that you see there. So this solves the problem of when people want to share information today, they'll often take a screenshot of it or something, and then the receiver of that screenshot would lose context of the rest of the web page. Thank you.
Thank you very much. So the next speaker is Sahel.
Hi everyone, I'm Sahel and I'm going to talk about overscroll customization. So developers use CSS Overscroll behavior properties to prevent some of the user-defined boundary actions like pull to refresh or history swipe navigation. Then they might want to use a combination of different event listeners to implement their or trigger their own customized overscroll boundary behavior. As is, there are some limitations, like they need to implement this for each type of methods of scrolling separately, or if there's an iframe, then the touch move or wheel events won't even bubble from the iframe. So to make developers' lives easier, what we want to do is we want to send events that makes the keeping track of the state of scrolling easier. So we're going to send overscroll event, which is async, non-cancelable, and it doesn't have a default action. The next event is scroll end. We're going to send it when telling the developer that the scrolling has finished and any ongoing animations related to scrolling has ended. So if any element has scrolled during the current scroll sequence, we're going to send these two events to the scroll element. If not, we're going to send it to the last element in the scroll chain. So I have two demos here. Both of them are like implementing their own customized pull to refresh. So what I did, I took this chatbox demo and I added the non-scrollable iframe over there. So here, using the touch move, the overscroll would, I'll play it again. The overscroll won't get triggered if you do the touch move over iframe. On the next slide, I don't know how to get to it. Okay, no, the previous one, sorry. Okay, so this is the same thing. They just use, I'm just using overscroll instead of the touch move. And you can see that doing the action over the iframe triggers the pull to refresh. The next slide, please. Okay, and this is just some status if you are interested to see what's the current status of the CSS property. And on the next slide, there are some links to the proposed spec. And that's it. Thank you.
Thank you very much. So the next speaker is Richard.
Hello, everybody. So I work at ARM in Chrome optimization team, and I have a ton of projects that I work on, which I've discussed with some of you, but including the crazy experiment in parallel styling. But at the last minute, I'm kind of impulsive, so I decided to change my talk and talk instead about Windows and Electron. So as anybody who has come by my desk recently at ARM will know, I've got a couple of exciting new devices. And these are the HP Envy X2 and the Lenovo Yoga C630, both based around Qualcomm Snapdragon devices. And the reason why they're exciting is because they kind of feel like proper laptops in a way that previous ARM laptops just kind of haven't. You can run Visual Studio on them if you want. You can compile on them. You can develop. They're really nice devices. And they come with some pretty good features, if I get the remote working. So when I say great battery life, I do mean all-day battery life. I've been using my device all day, and I'm still only 75% charged. So that's pretty good. And they also have neat 4G and stuff like that. The problem is that if you go and download Chrome on one of these devices today, it will run under backwards compatibility emulation. And this means that actually the device doesn't feel as quick as it should. So our first job when this kind of landed on my desk was to get Chromium running really well natively. And by December, we mostly had the port up and running with a lot of patches and stuff at this stage. Since then, we've kind of made, a lot of the patches have gone away, and we're now actually performing really well on Windows and ARM. So next, we want to bring all of that native performance to Electron, and we've discussed a lot about what Electron means. It's quite widely adopted. It's a good way of reducing our kind of app gap of stuff that doesn't really work very well on Windows and ARM. So by January, we have mostly everything working. So we ported all of the core components of Electron, fast-forwarded through some major versions of V8 inside Electron Node and so on. But things weren't quite ready for release yet. You'll notice that in this VS Code build, there's no syntax highlighting or anything else useful like that, which you might actually want in, I don't know, a text editor. And it turns out that actually getting native modules working was the most difficult part of the whole port. So first they wouldn't compile because they were too old against the V8 API. They wouldn't link because we couldn't figure out where to get the right lib from. And then finally, whenever they got loaded into the Electron process, they wouldn't work. They'd crash the process. So eventually, after spending weeks and weeks and weeks and weeks on this, I found 2 client compiler bugs, which
Hey, I'm Hannes from the V8 team. Part of my team and I are working on garbage collection in V8 and Alpen. And today I'm going to play a game with you. It's called Sokoban, the Memory Fragmentation Edition. Let's hit the start button, it works. It's only single player so far, but yeah, let's do that. And the game is pretty simple. It's like, can you fit an arbitrary size box on a game board with arbitrary size holes? And obviously, these boxes should be objects of different size, and the game board is the heap. And if you get a layout like that, it may be pretty frustrating. You stare at the screen for a while, and suddenly you get a game over out of memory error, which is really unfortunate. If the game board looks like that, well, it's pretty simple. You find a spot. It's getting even simpler if it looks like that. It's nicer if it looks like that, because there you actually only need half of the game board and can free up some memory. So the relation of allocated live objects and committed memory of the heap, it's called fragmentation. We can measure that. We have numbers in UMA. And this typically, memory fragmentation is typically a 99 percentile problem. If you look at different allocators we have in the renderer, malloc has 99 percentile fragmentation of 36%. This is a very typical number for malloc. We see that also in other software systems. Alpen is mostly a non-moving garbage collector, and so on the 99 percentile, it looks like it is like a completely non-moving collector. It has like the same fragmentation as malloc. Whereas V8 is a mostly moving collector. We have an SLO in V8 that tells us, well, tells the GC it should stick around 10%, and 9 percentile it's 11%, so that works well. Okay, let's make the game a bit more fun. Let's get a little character that helps us. That's obviously the GC, who can move objects around. And you can organize your heap like that. But wait, there's one problem. What if these boxes have references to each other? So what happens if the character moves boxes and doesn't update the references? Obviously, you're going to crash because you are going to access memory that is maybe used by some other object by now. So the character or the garbage collector has to know where the references are that were pointing to objects that were moved, and it has to update them. And ideally do that in parallel or even to concurrently to remove shank. But that only really works if you have a precise garbage collector. Precise means we know exactly where all the references are. V8 has that. Unfortunately, Alpen does not. Like, we don't know for Blink what's on the stack. That's okay if you only do marking. We had a talk about that today, but it doesn't work for compaction. So the proposal is, let's make Alpen a precise garbage collector, then make it a multiplayer game. So let's take advantage of multi-core to do compaction in parallel, and game on.
Thank you very much. So the next speaker is Santiago.
Hi, I'm Santiago. I'm here to talk to you about pointer compression on V8. Basically, we have the 64-bit value, and we want to compress it down to 32 bits. That's all we need. And for that, we need the help of the V8 desktop, Chase Foundations, and the mobile team, which is the where I'm at. Why do we do this? Because on the heap, about 70% of it is used by tag values. So if we can compress them down to 32, we will be saving about 35% of it. The bad part is that we need to do some more work. In the case that we want to use this 32-bit, then we need to uncompress it. In the current scheme that we have, we can address 4 gigabytes of space for the heap objects. And what we do, we have a base pointer, and then we can address 2 gigabytes on this side and 2 gigabytes on the other side. For compressing, it's just casting it to int32. And for decompressing, we cast back to int64. But also in the case of pointers, we have to add the base pointer to it. We have a really good numbers for memory savings on Facebook. On performance, we are experimenting some regressions, but fortunately, we have some improvements on ARM64 and Octane. The next steps will be some removing some unnecessary compression and decompression, because right now we're doing it every time we load and store, shipping, addressing some performance issues, setting up some fringe experiments, hopefully applying the same technique to Blink and C++ heap. Thank you.
Thank you very much. So the next speaker is Vadim.
Hello, my name is Vadim Petrov. I am the head of the rendering team in Yandex browser. And I also response for the techno projects in browser department. I would like to speak about one of these projects, first snippet optimization. Many websites have a hero element. It is the most useful and significant element which website needs to render as soon as possible. The main page for Yandex, and I suppose for Google too, is the search engine results page. And the hero element for this page is the first result of the search, the first snippet. By default, browser does not know what is the hero element on the search page and draws almost all results in the first frame. So first snippet is delayed. But website knows what is the hero element and can mark it by some custom tags. So we can generate algorithm here. Browser loads page as usual, but when HTML parser encounters custom tag parsers run stat, HTML parsers receives maximum CPU budget for synchronized parsing. Next, HTML parser encounters custom tag parser run end and stops parsing. Now browser directs all resources to rendering. It is very easy algorithm, isn't it? And an effect for Yandex search engine result page is pretty good. We improved first snippet paying time by 10% on average, and for 19th percentiles, more than 20%. And also, we improved website product metrics. Thank you.
Oh, thank you very much. So the next speaker is Mario.
Hi. Yeah, this should be it. So I'm Mario. I work at the Galia's Chromium team. I'm going to try to give you a very, very quick and high-level overview of the upstream contributions we've been making to the project this year. Sorry for speaking fast. Servicification, in this case, we work on the migration to the new APIs of the network service and the identity service, landing like quite a bunch of patches during this collaboration that I want to believe that they resulted in making Chromium better and preparing it for the future. For Onion Soup and Cold Health, this is an ongoing collaboration. Thank you. That started 2 months ago, and we landed quite a bunch of CLs as well, of all kinds. Well, for instance, like we make more Blink classes garbage collectible, all this list that I don't have time to go through right now. CSS, web platform team. We have a web platform team that has kept working as usual on implementing new features and keeping up to date with the specs, doing bug fixing on several CSS specifications. Oh my God. Accessibility. In this front, I'm very happy. I used to work in accessibility, and I'm happy to say that now Chromium supports basic accessibility in Linux, both in the UI and Blink content. And also that Chromium has now two new owners that I think is good news as well for the project. Thank you. More work to be done. Hopefully we'll have something very usable by the end of September. V8, a compilers team as well have been busy working implementing many things like the front-end method, doing optimizations, and they are busy working on private methods and adding support for Begin in the WebAssembly API, among other things. Also on Wayland, Maxine gave a talk yesterday, so just to say that it's fully upstream right now, and we are working on filling the missing bits. Also, 2 more new owners in here. MathML, Fred and Rob gave another talk, so just to mention, we have a work in progress branch implementing support based on layout NG, and we plan to refine our string during 2019, and several other things that you can read when you have time. I don't. And now to finish some numbers, I'm very happy because according to this, we are the second biggest contributors in number of commits. Thank you. Third contributor, if you read the small letter, the small chats, because I was not considering Chromium addresses, because it's hard to know who they belong to, but anyway, it's still good, with more than 1,500 commits. If we consider also the commits that we had in the V8 repository, those ones were for Chromium only, we have a few more. But even more importantly, I'm happy to see this growing trend that shows you our commitment to the project. And all this is possible because of the 24 Italians that have been contributing that are all in there. Thank you very much. I can't believe I made it.
Thank you very much. So the next speaker is Mike.
Thank you. Mike Taylor, lead graphic designer at Mozilla. Every single one of my slides was made for applause. I don't know. Every single one. Anyways, yeah, we're trying to figure out oh yeah. Also, not everything I say needs to be taken literally. Trying to work on web compatibility metrics, trying to understand, like, is there a gap between Gecko and Blink, and can we measure that? And so this is kind of a first attempt, like, can we look at all the features that have a use counter in Chromium and do some math with some fancy Greek letters? We'll skip the algorithm, but here's what it looks like essentially. Like, so mouse event 2 element, it's used 42% page loads used, quote unquote. So we don't support that, so let's add it up, but like document.all, we've had that, so you get some kind of like DOM value like this. So here's what this would look like for CSS. CSS properties coverage is pretty good. You can see between 62 and 63, this gap got smaller, so that's pretty good because we shipped WebKit appearance. We also were taking a look at the gap size. This is just like the total amount of CSS properties supported by Firefox and supported by Blink and the difference there. It shot up quite a bit in the recent past. I think it's scroll snapping. So potentially an interesting thing to pursue, but there's problems, right? CSS properties were good. CSS property values, there's no information there. DOM is really more problematic. Only about 5% of the properties supported by Blink and not by Gecko have use counters. So basically, we're just going to go back and figure out how to estimate and do this work. I did some back of the paper math last night, and I came up with an easier solution. And if just going to throw that out on the table, if Chrome wants to switch to Gecko, this number goes to 0 overnight. So thank you.
Thank you very much. So the next speaker is Gokai.
Hello everyone, my name is Guokai Chen. I'm from UC Browser. Today I will introduce a web feature that makes game more. This feature is developed by the UC Browser team, used in H5 game situation to improve the game performance and reduce power consumption. We find that a lot of H5 games are full screen. It may just use only one canvas element for WebGL to draw the game contents. In this situation, the web engine graphics pipeline seems to be a complete design. It has so many threads, a lot of synchronization operations. This complete design will make more CPU costs and degrade the performance. So in the game mode designs, we will translate all the WebGL commands to the GPU thread from Blink main thread with commit buffer half, and then execute all the GL commands in the GPU thread and swap the result frame buffer to a native window that provides by an independent service view. In this device, we don't need to composite frames by the Chrome compositor. It has less stress and not so many synchronization operations. So it can gain 10% performance improvements and reduce 30% power consumption. Well, we know. Thank you. We know that there is some situation may have a few DOM elements in the H5 games, like the demo of the slide. There is some small buttons in the top right corner. So we know the canvas for WebGL is drawn to be an independent service view. So how does the other DOM elements do? How can we make these elements become visible and response user even normal? The secret is in the web view. Different to the canvas for WebGL, we will still draw the other DOM elements to the web view. And then in order to make these elements become visible, we will put the service view below the web view. And then we will clear the layer which below the web view and below the canvas and make the intersection layer transparent. It looks like we dig a hole in the web view, so the service view below the web view will become visible, and the DOM elements on board the canvas can also be seen. Because this small number of DOM elements does not update frequently, so it does not impact the result of game mode. We still can gain 10% performance and
Thank you very much. So the next speaker is Daniel.
So, hi everyone. There's been a lot of talk about compile times this BlinkOn, and lots of talk about GOMA. I want to talk about another approach to improving compile times. With GOMA, you throw a lot of hardware, lots of resources on the build, and you make it much faster. But if you don't have much resources, then Jumbo might be the solution. So Jumbo is a Unity build system, and it works by combining a lot of CC files in a single translation unit. This really helps because in C++ you spend a lot of time compiling headers and expanding templates. If you instead put all of these files in a single translation unit, you only parse and compile the headers once. Since last year, we haven't done that much, but there was a guy that added support for Jumbo in Chrome browser UI, and that cut 10% of the Jumbo compile time. Yeah. And we also have a GN fork with native Jumbo now. Maybe we don't want it to be a fork, but it is a fork. The most interesting part here is probably how the compile times have moved the last couple of years, or the last year. So we can see that the compile time keep increasing, and a couple of weeks ago it was almost reaching 6 hours on the reference hardware, which is a 4-core, 8-thread Linux machine. When we added Jumbo, we got quite quickly to twice the compile speed, and then 3 times the compile speed, and it's now about 4 times the compile speed. But the most obvious the most interesting part of this graph is maybe the drop at the end. And here I want to thank the Clang team that gave us a new Clang compiler without the bug code, and we have 20% faster compiles, Jumbo and Jumbo. So this is really good. Thank you, Clang team. If we want to keep improving this, press the right button. There's a few parts left to go add Jumbo to, but I don't know how much it's worth it. So, thank you.
Thank you very much. So the next speaker is Taekwon.
Hi everyone, my name is Taekwon from Samsung Electronics. Today I'll talk about the consumer electronics company's needs for the edge distributed Chromium. We have lots of things at home. We have a TV, we have a fridge, we have smartphone, we have laundry. We have many devices at home, and these are getting smarter and smarter. By meaning smarter, it means that we have a browser enabled on these devices. And on these devices, we can run AI contents. We can even run the AI contents on these devices. But the problem is the things are getting smaller and smaller. We started from PC, but we can now run the JavaScript on fridge, laundry, and Galaxy Watch, and these kind of small devices. So to run these complex content on these small devices, we need a new solution. So current Chromium, we have a multi-process model on a single device. With this model, we cannot borrow any power from other device. So we propose a new model, which is a multi-process on a multi-device. If you run some process, if you offload some process to the multi-device, you can borrow their power from the powerful devices. So we propose castanets, which enables the browser on low-end devices. So what we do is we run the render process, which runs the JavaScript and those complex layout parsing and those kind of complex things on the render process on super smart devices such as a laptop, smartphone, and smart TVs. And you just get the graphical result in the browser process. So we'll show you the castanets in action. You can get the much faster JavaScript execution. Can you try to run the videos, please? So now we are running the browser process on the small device and render process on the Android phone. And if you run the maze, you load a web page and you run you try to solve the maze problem. And within a second, you get the result from the render process. How do you go next? Yeah, so we're doing this project, and you're welcome to contribute. Please check out the site, and please start a GitHub page. Thank you.
Thank you very much. So the final speaker is Gab.
Woo! All right, last one today. I'm Gab from Google Montreal. Hope you're still awake, because this one's going to be interactive. I hope to demystify long-tail performance analysis today. So let's look at this. We have a trace where we have a layout for 1.1 second. What could cause that? Say it, say it, say it. You're too right. But most of you, what I hear is descheduling. It was descheduled, not my fault. This is not the culprit you are looking for. Recently, we added, there we go. Recently, we added, if you enable the base category in tracing, we have scope blocking calls, which if you're using waitable events or anything in base, is going to add and record when you are blocked in one of our primitives. So here we say we actually blocked in things that we invoked ourselves, and these have a source file, like from here info. So now we know that this is indeed in fonts. And if we look, that font proxy thread at the bottom, which looks fairly inactive, is actually proxying to the browser thread. And before we knew this was font, all we could tell is that this task scheduler task at the top was a Mojo notify coming from Mojo. So you're like, what is this? But now that we know this is fonts, we added we enabled the font tracing category, and we added more trace events there. And then we know that we're actually in the font proxy, and then we can at least start figuring out how to solve the problem rather than saying, I'm descheduled, not my fault. All right, what about when we hit code that's not instrumented by base, and so you don't have those call blocking calls, you don't know where you're actually blocked. There we go. We also have sampling profiler now in tracing, so you can enable sampling profiler, and you can get stacks. So in this case, we can see that we're in image decode. So at least we can say something better than I was descheduled. Takeaways: do not assume Longtail Performance is being descheduled. This has never, ever been the case, and every single one we've looked at, we've seen lock-in versions in base, we've seen kernel lock-in versions, we've seen tons of stuff. Descheduling is never the issue. Instrument, 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 and if you're not sure, reach out to us at katanteam@chromium.org. That's it.
So thank you very much. We are on time. So I'm so happy about having speakers from Mozilla, Samsung, LG, and so many organizations. I'm super happy about it. And finally, so we have a special lightning talk speaker today. So I want to invite the special speaker to the stage. Ben Goodger.
Thanks, everyone. Hi, I'm Ben Goodger. I'm the pointy-haired manager over the web platform team at Google. It's great, so great to see everyone here today. Who is excited to have BlinkOn in Canada? It's really awesome. Every time I travel to an event like this, I am reminded, and it really brings home the fact that the web is a global community. And that's just such an important part of it, and it's a really important part of the experience. And for me too, when I look at my story, the journey that I've taken over the years, when I got into software development, starting as a teenager, building websites offline because I couldn't afford an internet connection, on the other side of the world, being exposed to people and their ideas in those small time slices that I had online, to be able to build interesting content and then watch the browsers evolve. It was really terrific. And then to be able to get involved in a browser project, Mozilla through open source, it really showed me that the web is the platform that has the most potential for being maximally inclusive, to draw in a broad range of perspectives, regardless of what background people come from. And related to that, open source is a way that is a maximally inclusive way of developing software. And so that's something that I've always been wanting to strive for as we build software in Chromium. And so in the early days of Chrome, back before we launched, we had a discussion. We wanted to be open source. How would we go about doing it? Certainly there are all manner of different models that we could have chosen. We could have dumped a source tarball over the wall every time we did a release, and that would have satisfied our legal requirements and so on. But then I thought back to the model that I got engaged with when I worked with engineers at Netscape early on, when they created an environment that was welcoming to people, even people who were teenagers who were just passionate about evolving the web and evolving browsers. And so I think it's absolutely awesome that we have other browser vendors with us here today, other corporations. I think that's awesome. We have so much leverage working together to be able to evolve this platform. But I also want to say that for me, the potential of this open source development model is also in the long tail of developers that we can reach. People who just have passion, who have their own interests, their own motivations. If we can create a project that is welcoming and inclusive for them, I think we will reach the web's true potential. So when I look at this room, I see it's great that we have representation from so many different offices and parts of the world. That's awesome. But I also see a lot of work ahead for us to continue to grow this community and make it more representative of the communities that we serve. And I think we need to be mindful of that. And so something that we can all do as we push forward on this is just to try and create a more transparent, more open, more welcoming development community that helps people engage with one another, share ideas, share their passions, and build on success. So that's basically the note that I wanted to share at the end of this. Thank you so much for coming. Thank you everyone who put together heaps of really valuable talks and just engaged in all of this discussion. It's been absolutely awesome. I'll see you next time.
Thank you very much, Ben Goodger. So we are done. So thank you everyone for joining the Lightning Talk session. So see you next time at the next BlinkOn. Thank you very much.
So I'd like to give a big thank you to Kentaro for organizing the lightning sessions. I think they're enormously enjoyable and a lot of work to coordinate. So thank you very much. A few other thank yous before we wrap up. I'd like to thank each and every one of you for taking the time to travel here. It's a lot of time out of your schedule. I think it's obviously you, the attendees, that make this such a valuable event. But I would also like to give a special shout out to the CBC crew, everyone here who organized all this event, and our closed captioning team that did an absolutely fantastic job. I did have a question for you. Who here thinks that a year is too long to wait for another BlinkOn? So there's some applause. So I'm pleased to be able to announce that we're planning the next BlinkOn. I can't share the details yet. It will be in roughly 6 months. And the goal is to move to a more frequent cadency going forward. So there will be more BlinkOns to come, and we look forward to seeing you soon. That's a wrap. Thanks so much for coming, everybody. Safe travels home.